Okay, in the spirit of better late than never, today's episode of Homework Help, actually 2 days ago's episode, is Solving Systems of Equations musical chairs. I'm doing 9, 11, and 18. Most of y'all did okay with these, but I still want to go through them just in case you had anybody needs to see them, okay? So let's look at number 9. Number 9 says 12x minus 4y equals 36. And y equals 2x plus 3. Now, I will tell you, I cannot tell you how many people, especially when you got a whole page full of these systems, I can't tell you how many people have been like, why is this wrong? And I realized they wrote one from one, like one equation from one problem and one from the other. Honestly, I know this seems strange to say, but the first step is always to make sure you wrote it down right, because I can't tell you how many times I've made that mistake. It is so easy and such a common mistake. So make sure you wrote down the right problem. So I'm going to check again. I have 12x minus 4y equals 36, y equals 2x plus 3. So I got the right thing. Okay, so now, the question I always ask myself, because again, now that we've got all 4 methods, well, at this point we had 3 methods under our belt, but what do I have? I have a standard form and I have a slope-intercept. I only have one isolated variable, so I can't put this one in my calculator, so I can't use the calculator to solve it. I only have one that's isolated, so I can't set equal. And even if I did have 2 that were isolated, they'd have to be the same thing isolated. And in this case, they absolutely aren't. So my method that I'm going to have to use here, since I have one isolated variable, is I'm going to have to use substitution. So what that means is everywhere I see a y, I'm going to stick 2x plus 3 in the other equation. So since I see a y there, I'm going to write everything I see, except when I get to this y, I'm going to put 2x plus 3 in parentheses. So let's see what that looks like. So I have 12x minus 4, and I see my y. So I'm going to put 2x plus 3 in its place. And then I'm going to keep going. I'm seeing a lot of people forget to put this equals 36, and that makes a huge difference. Because then, remember, we're setting both sides equal. If you get rid of the equal sign, you don't have 2 sides to set equal, and then you kind of forget. You're like, I got to get everything on the same side of the equal sign, but if you don't have an equal sign, you forget. It gets confusing. Make sure you bring everything you want used down. The equal and the 36 are critical. Don't leave anything behind, okay? So now I'm going to start solving. First step, we hate fractions. No fractions here. Second step is to distribute. And I do see distribution right here. Remember, the negative is part of that problem, so we're going to distribute it too. 12x is a leftover. I didn't mess with it, but now I'm going to start distributing. Negative 4 times 2 is negative 8x. Negative 4 times 3 is negative 12. And then equals 36 comes down because I didn't do anything to it. It's a leftover. All the leftovers come back down. Okay? Now I start combining like terms. 12x minus 8x is 4x. I didn't mess with negative 12, and I didn't mess with 36. Remember, the equal sign comes down too. Some of you like to put the line down the middle. That is fine. And that might be helpful because if you don't have a line, if you don't have an equal sign, you're going to have to put your line through. So if that helps you, do it. So if it helps you to put the line here, so I know I got to have an equal sign here, and I got to have something on the other side of this line, that'll help you. Okay? Now I'm going to add 12 to both sides. And this zeroes out, leaving me 4x equals 48. When I divide both sides by 4, I get x equals 12. Okay, so I think that x is 12. I'm going to go back to one of these equations and substitute it in. Now, I could easily substitute it into this first one, but the second one looks easier to me because since I'm trying to find y, and y is by itself, I don't have to worry about there being stuff on both sides of the equal sign. Okay, so that's what I'm going to use. Y equals 2x plus 3. I know that x is 12, so y equals 2 times 12 plus 3. Means y equals 24 plus 3. That means y equals 27. If I'm right, when I plug it all back into here, I'm going to get an answer that's like correct. Okay, so let's do our checking step. Again, I see a lot of people skipping the checking step. It's so easy to do, and it makes sure you get the right answer. And we like to be right, so let's do that. Okay, so 12 times x, which is 12, minus 4 times y, which is 27, should equal 36. Okay, well, I'm going to have to use my calculator again. Well, no, 12 times 12 is 144. I know that. Oh, I'm sorry, that's a minus sign. But I don't know what 4 times 27 is. 4 times 27 is 108. that should equal 36. Well, what is 104 minus 88? Whoopsie. It is 36. So I know I did this one correct. That means my answer, since this is not a word problem, I don't have to write a word answer. I just write an ordered pair, which is 12, 27. Okay? Let's look at 11. 11 is x equals 2y plus 3, 2x plus 4y equals 22. Okay, once again, when I look at this problem, I see 1 with x by itself, so I can't stick that in the calculator anyway. I see another one that's in standard form, so I can't use the calculator. I can't use setting equal. I only have one isolated variable, so I have to use substitution. That means I'm going to put this 2y plus 3 anywhere I see an x. So 2 times 2y plus 3 plus 4y equals 22. I'm going to distribute. I get 4y plus 6 equals 4y. I'm sorry, plus 4y equals 22. 4y plus 4y is 8y plus 6 equals 22. I subtract 6 from both sides. I get 8y equals 16, which means that y is 2. According to my work, y is 2. I'm going to plug it in and find x. Again, I could use this one, but that one looks easier because I want to find x. X is by itself. I won't have to do any working backwards. There may come a time soon where you have no choice but to work backwards and use a standard form because that's all you'll have. But if I have a choice, I'm going to use one with an isolated variable. So x equals 2 times y. Y is 2 plus 3. That means 4 plus 3, which means x is 7. So I'm going to confirm with this last equation. 2 times x, which is 7, plus 4 times 2, which is y, should equal 22. 14 plus 8 does equal 22. So even though I got y first, I always write my ordered pair as xy, so I'm going to write 7, 2 as my answer. Okay? Let's look at the last one. The last one I have is number 18. 18 is x plus 6y equals 100, and x equals 3y minus 8. So again, I ask myself, what method am I going to use? Well, I can't use graphing because I have an equation set equal, I don't have something set equal to y. I can only put y equals stuff in my calculator. I can't use setting equal because this one isn't set equal to x. If they were both set equal to x, I would use setting equal. And so, since I have an isolated variable, my strategy has to be substitution. So anywhere I see an x in the other equation, I'm going to plug in 3y minus 8. So 3y minus 8 plus 6y equals 100. 3y plus 6y is 9y minus 8 equals 100. I'm sorry. I'm going to add 8 to both sides. 9y equals 108. And that means y is 12. Let me check my work there. 12 times 9 does give me 108, so I'm in good shape there. So I think y is 12. I'm going to plug it in to check again. I'm going to use the easiest one to solve. Anytime I have a variable that's isolated, that's usually going to be the easier one to solve. X equals 3y, which is 12 minus 8, which means x is 36 minus 8, which means x is 28. Is that right? 3 times 12, let's see, 12 is 36 minus 8. That is 28. So now I'm going to plug them back into this original equation and see if I get a true statement. 28 plus 6 times y, which is 12, should equal 100. Well, what's 6 times 12? 6 times 12 is, I think, 72. Let's confirm. Okay. So 28 plus 72 should equal 100, which it does. So my solution is 28, 12. All right.